Hi, Assalamualaikum. My name is Hakim Zulkifli, CF18008. So today I will discuss about unconfined compressive tests. So my part is about the introduction and the review study. For the introduction, unconfined compressive tests to investigate the property strength of soil. The laboratory test is used to determine the maximum exit compressive stress that can bear under zero confining stress. It widely sustainable and also acceptable when derived the soil investigate as a quality control measure, such as an undrained stress and drain strength characteristic. The test is inexpensive and the data can be get very quickly, and also the procedures is not complicated to handle. It used vastly because it's easy to handle compared to direct shear test and triaxial test. For the literature review, a review about the Badrun Nizam Ismail and etc. 2020 on the estimation of unconfined compression test UCT parameters using digital image analysis. Okay, the article focus on discuss about the unconfined compressive test parameters by using the digital image analysis. The article background investigate the property strength of soil. Okay, from there can help to understand the properties of rocks and fine-grained soils mechanically that provide a measures of the stress strain properties and under stress strain of rock or soil. It often includes the laboratory testing program of geotechnic investigation, especially when dealing with rocks. On the experiments and the method. Okay, the soil collected at UITM Pulau Pinang. There's the coordinate. Okay, by using the MATLAB software to get binary image every 20 seconds. So it will from the image every 20 seconds they analyze the image and transfer to Microsoft Excel for further observation. So all the vertical and horizontal dimension was counted as the change of middle row and considered as the horizontal deformation is quite similar for the whole height of the samples. And the result, the alternate method to determine the parameters from unconfined compressive tests that they build can be applied. Can be applied for the industry as more affordable from other advanced equipment. Based on the stress strain curve, the digital measurement is slightly higher than the manual measurement, and the Poisson ratio shows fluctual values as the theoretical the Poisson ratio value are acceptable and valid for the linear elastic part. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shakil Karafi bin Chef Walzman. Today I will present about my project, which is unconfined compression test, which is my part is the purpose of this test, unconfined compression test. So the purpose of the test is to basically the general purpose for this testing is to quickly determine a measure of unconfined compression strength of rocks or fine-grained soils that pose a sufficient cohesion to permit testing in the unconfined state. This measure is then used to calculate and consolidate undrained shear strength of the clay under unconfined condition. So the advantages and disadvantages of this testing is for advantages, it gives a quick and simple measurement of the undrained strength of cohesive undisturbed soil specimen. Expensive, allow for rapid drainage of fine grain. So the disadvantage of this test is not suitable for disturbance sample in case the sample obtained from thin wall tube. Although the method tries to simulate or duplicate the pressure on the site, it will not properly the same pressure with actually on site. The soil condition at initial state and during the test cannot be controlled and measured. is only for drain condition, and it will give a non-uniform distribution of strain and stress data. So that's all the advantages and disadvantages. So for this project, we use this parameter and properties. So this parameter. So this data is from Ideal Engineering Laboratory Sdn Bhd from project development at this slot, which is at Muking Tanjung Seberang, daerah Johor Bahru. So this parameter for UC, so this is the maximum UCT result from this report. So we summary in this table. So we will use this unconfined convergence strength, this maximum value in the Plexis 2D. So that's all from me. Thank you.
So I will continue our presentation with procedure in modeling UCS using Plexis 2D. In modeling UCS, there are several steps where need to be done. The first step is to define the limit of the soil contour. In this project, the maximum horizontal contour at SMAC was set to 140 meter, and the minimum horizontal contour was 0 meter. The vertical contour YMAX was set to 10 meter and Y minimum is 30 meter. Element with 50 node were chosen in order to increase the accuracy, and the model will be in plane strain. The below figure show the project properties. So second is to define the embankment geometry by creating a soil polygon as shown figure 4.2, and next to create soil layer, borehole should be created and thickness of each soil layer, the groundwater level should be set. So that after that, soil layer have been defined. Next step is to model the UCS. In order to model UCS, 3 different type of soil materials such as hardening soil, undrained soil, and soft soil undrained.
Now I want to continue the fourth step, which was defining the soil properties according to the value mentioned in table 3.1 in previous chapter. For embankment fill, whether crust layer and sandy clay will be more column model because it is used to define shear strength. For embankment fill, behavior will set to drain in order for the stiffness and strength are defined in terms of effective properties. As for other soil layer, behavior will be set to undrained A, where large bulk in stiffness for water is automatically applied to make the soil as a whole incompressible and calculating excess pore pressure. Another material model to be used for the soft soil layers was soft soil model because it is suitable for soft type of soil. Figure 4.4a shows the material set, while figure 4.4b defining material properties. Once the geometry model had been fully defined, the geometry has to be divided into finite element in order to perform the finite element calculation. This can be done by clicking generating mesh button. Choosing medium mesh should be fine, as very fine mesh will be lead to excessive calculation time. Figure 4.5a shows generating mesh menu, and figure 1.5b shows the example of generated. Next step will defining the ground level water. For this project, the water level was maintained at negative 0.5 meter from surface. Below shows the groundwater level menu and shows the position of groundwater level for this project. Calculation stage will be the next step for the modeling procedure. For this project, the phase in the calculation stage will be different according to the proposed condition. For surcharge rate of 2 meter per week, the phases involved were initial phase, phase 1 embankment 142 meter, phase 2 consolidation 1, phase 2 Phase 3 embankment 2 for 2 meter and phase 4 consolidation 2 for surcharge rate of 4 meter per week. The phases involve only initial phase. Phase 1 embankment for 4 meter and phase 2 consolidation. For the embankment, it was constructed with time interval of 7 days for each phase of embankment fill, whereas for consolidation will be 30 days. However, the last phase of consolidation, the loading type will be minimum access pore pressure to see how long the consolidation process to end. The last step before generating the result will be the point selection. The point for this project will be 2 points, each for settlement, access pore pressure for settlement. The point coordinate will be point A 00, while point B 2.5 -4 will be used for access pore pressure. That's all from me. Thank you.
Good morning, my name is Yap Zining. Today I am going to present about the discussion part. On the table attached in the slide, we can see that the hardening soil has revealed the lower settlement, while the soft soil model has demonstrated the highest settlement, which is equal to 4.994 times 10 power of -12 meter. So now I will briefly explain about the soil model. The first one is the hardening soil models. It requires 9 parameters, including 3 reference stiffness parameters. For example, the second modulus for the triaxial compactions, or the unloading reloading stiffness for triaxial unloading reloading, also the tangent autometric modulus for autometer loading, as well as the power of M for the stress dependent stiffness formulation. So we can see that the hardening soil has input many stiffness parameters. In a contrast, most column models only consist of 5 general input parameters, which is stiffness and Poisson ratios for the soil elasticity. Besides, it also consists of friction of angle and cohesion for soil plasticity, as well as the angle of dilatancy. The hardening soil also consists of these 5 general input parameters. So in other words, hardening soil models is an advanced version of more column with the input with stiffness parameters. So here attached the lab result which demonstrated when we can get our general parameters such as cohesions, friction or angle for our more column and hardening soils models. For soft soil models, we have chosen the method of undrained A, as they has 3 types of undrained method. However, method undrained A is chosen as it allows the soil behavior to be ruled by the effective stress in terms or instead of the pore pressure. By selecting this method, the practice software is able to make a distinguish between effective stress and excess pore pressures. During stroke loading of a soft soil, the pore pressures increase, and as a result of an undrained response, hence the effective stress reduced. So that is the reason why the settlement amongst the other model, the soft soil models reveal the higher settlement rate. In a contrast, as mentioned before, the hardening soil models is advanced models with extra input with the stiffness parameters, so it has recorded the lower settlement. After that, we have plot a graph of divided stress against the strength From the graph given, we can see that the soft soil model has the highest agreement with the experimental result. So we can conclude that the soft soil model is the most suitable model we should employ in our study. Can be supported by the hydrometer analysis result from our lab report. We can see that for borehole 3, it was consisted of 63% of sand, which is soft soils.